else. So in this video we are looking at something called point slope equation or point slope form of a line. So in the last section we saw a slope intercept where if we knew the slope and we knew the y-intercept we could write an equation. For this section, if we have the slope and a point, we can write the equation. And frequently we do not leave the equation in this form. We often distribute the m through and incorporate this thing that's going to be this y1 over to this side, and we end up in slope-intercept form at the end. So this one is often more of a way to get to slope-intercept than like an ending spot for itself. In terms of this equation, it is actually just our equation for finding slope. If I divided both sides of this by x minus x1, get my pen out, this would end up y minus y1 over x minus x1 equals slope, which looks a lot like our y2 minus y1, x2 minus x1. So this really is the same thing as a slope equation. They relabeled the x's and y's a little bit to make it the variable xy and a single point x1, y1. But it is an equation that we saw a couple of sections ago. So let's see how this works, and it is pretty straightforward. If you have a point and you have a slope, you chunk them in here and clean it up and you'll have the equation of your line. Oh, and then the three things we're looking at in this section is first, given a point and a slope, find the point slope, or find the equation of the line. Second is given 2 points, then find the equation of the line. And remember from before, if we have 2 points, we can get slope. So we're basically going to just reduce it down to this first case. And then the last thing is same thing, point slope, but in context. So there would be words involved, and we have to figure out what our points are and what our independent and dependent variable are in order to write the equation. So with that, let's look at number 18 here. Find the equation of the line with a slope of 3/5 that goes through the point 5, negative 10. Write your answer in slope-intercept form. Okay, so let's write out our point slope form just to kind of get used to using it. And so we know, oops, let me do that. Sorry, let me check this real quick. There we go, let me make that a little bolder. So we know that our slope is 3/5, and we know that our point is 5, negative 10. So that 5, negative 10 is going to be the x1 and the y1. So let's get all that set up in here. So y minus, careful right there, that minus and negative 10. It's easy to miss that double negative. Our slope is 3/5, and then x minus 5. And then we'll clean this up a little bit and see where we get to. So y minus a negative 10 would be y plus 10. And I'll distribute that 3/5 through, and that'll give me 3/5 x, and then 3/5 of 5, those 5's would cancel, and I would be left with negative 3 up top. And let me just write that over here. We think of this 5 as over a 1, and so those are canceling. So 3 times negative 1 makes negative 3. And then the only thing I have to do from there to finish that off is finish getting y by itself. So I'll subtract 10 off of both sides. And we have y equals 3/5 x minus 13. And that would be our equation in slope-intercept form. And this is pretty much what there is to finding an equation of line. Once you know your slope and your point, you just chunk them in here, clean it up, and that's going to get you to your answer every time. So now we're at what the rest of the section is going to do is give us 2 points. So we have a couple of steps we got to do. We're going to have to find our slope given these 2 points, which we did a couple of sections ago. Once we have that, then we're basically right back to here. So for this one, find the equation line that goes through these 2 points, write your answer in slope-intercept form again. So first thing we're going to do is get our slope. And so remember that is from the previous section, y2 minus y1, and then x2 minus x1. So up here we'd have negative 31 minus 17. Remember I could let either of these points equal the x1, y1, x2, y2. Just be consistent. If this is x1, that has to be y1. And then 8 minus a negative 8. So let's see, that is going to come out to negative 48 up top. And then minus and minus, that's a plus, so that would be a 16 right there. And then that should reduce down to negative 3. And now that I have a slope and I have a point, I'm going to use this one with slightly smaller numbers, I think. It doesn't really matter, they're both kind of ugly. I can go right back like I did in the last equation and use my point slope form to find my final equation. Now let's write this out. One more example. So we'll let 17 be y1. And again, if we'd use this point, we would get the exact same answer. So it doesn't matter at all which one you pick. If one looks easier, pick that one. We decided our slope is negative 3. And then minus x1, so that's minus a negative 8. So this will be y minus 17. And let me clean that up first. So negative 3, we'll change that to a plus 8. And you could also just kind of go, it's going to be a plus 8 and distribute at the same time, but there it is. So negative 3x and then a minus 24 right there. And you can tell that up here because there were 1, 2, 3 negative signs, so that means it's going to come up negative. And then we'll just add that 17 over and we got it. That is pretty much it. So y equals negative 3x, and then that would be 3 and 4 for 7, minus 7. These next ones use, I think all the problems I'm about to do is this exact same math. So once you kind of have this, use your points to get your slope, and then use a point and a slope to get the equation. That's pretty much the drill for these last 3 examples. What makes these ones a little harder is that there are words involved, and so we have to kind of give those a read and then figure out what our 2 points are given the particulars of the problem. So for this one it goes, in 1993 the moose population in the park was measured to be 1,200. In 1996 the population was measured again to be 2,200. The population continues to change linearly. Find a formula for the moose population P in terms of T in the years since 1990. So there's a couple of kind of big pieces of information right here that we need to suss out. The first one is right here, the years since 1990. So instead of using kind of these giant numbers, 1993 and 1996, to plug into our equation or to set up our equation, they're simplifying this a little bit and saying start counting at 1990, so that would be t equals 0. So that means 1993 is going to be 3, and 1996 is going to be 6 when we go to set these up. So that's kind of the first bit. And then the second thing is right here. P in terms of t. So when they write in terms of a variable, that means that's your independent variable or your input. And so we would have t is going to be like our x. We're putting in time and we're getting out population. And it's really worth it to decide how that is going to look so that you make sure you get everything in the right order. In terms of which one is going to be kind of your x and which one is your y. So now we have those 2. I always like to write out the points in terms of whatever it's set up here, just nice and clean so I can kind of see what I got. So in the 3rd year, the population was 1,200. So in the 3rd year, we get 1,200 moose. And in the 6th year, there were 2,200 moose. And now I'm basically, if you look back, everything else is the same from here on out, because the only difference was here they just kind of said the points are this. For this problem I had to do a little bit of reading to kind of get myself set up to identify what those 2 data points are. So from there let's go ahead and solve this. So we'd have our slope first, and so we'll do our y2 minus y1 over x2 minus x1, and so that will be 1,000 over 3, which, yeah, that's right, this is one where the slope didn't clean up to something nice. You want to just leave it as this. If you try to write that as a decimal, you're going to have to round the decimal, and that's actually going to make the answer wrong. So even though it's kind of an ugly improper fraction, it is reduced, and that's exactly how we want that to look. And then we'll go to our point slope form, and I'm going to be careful to use p for y and t for x. So we would have p minus, I'm going to use the smaller of the 2 points here, so minus 1200 equals 1000 over 3, and then that's times t is our x, so t minus 3. And you can see right there the 3's are going to cancel when I distribute. That's why you don't want that as a decimal. This would come out to some kind of crazy number if you tried to do it that way. And it would be wrong, so that's another good reason not to do it that way. So that'd be 1000 over 3 times t, so there's our slope. And then again, distributing those cancel, and the 3's would be gone, so I would just have minus 1000 right there. And then I'll add this 1200 over, and then that'll be it. So population equals 1000 over 3 times t, and then adding that I should have 200. The question doesn't ask for it, but if we were asked to interpret what is this equation doing, this means that t equals 0, there were 200 moose, and every 3 years we're increasing by 1,000. So that's our starting point was 200 moose, like we saw in the last section. And then in terms of our rate of change, this is change in moose over change in time. So we're increasing the population by 1,000 every 3 years. You can kind of see that from here. In 1993, it was 1,200. So if we're increasing 300 increasing 1,000 every 3 years, there's that 200 plus 1,000 to get there. This one we got at the end of the 6th month of the year, you've saved $365. At the end of the 11th month of the year, you've saved $500. Write an equation to model this situation. Use months for S, or use M for months, S for savings. So I happen to have looked ahead, and the next problem is inconsistent in the way that they listed this. Time is almost always your independent variable. Like 99% of the time, if there's a time listed in the problem, it's your independent. And in this case, they did list this in the right order, and they're saying when t is 6, or I guess when m is 6, the savings is this much. So that does help me set that up a little bit. In the next example, they were inconsistent, and they actually wrote these backwards, but we'll look at that in a second. So we're going to have m be our input variable, and then savings S be our output. So again, I like to just write out those points. So when the months are 6, the money is $365. And in the 11th month, the money saved is $500. So we'll find our slope, and then we'll use a point in the slope to get our equation. So like I said, once you kind of get the hang of how to solve these, it's pretty consistent. The trickiest part is just kind of getting those points out of the verbal description given. So slope, that's annoying that they used m already. Let me undo that. And I'm going to actually write out slope then. Will equal 500 minus 365 and 11 minus 6. So it'll be 135 over 5. And 5 goes into that 27 times. And then as usual, I usually pick the smaller of the 2 points just to make the math a little easier. So we will not go y. We'll use the variables they told us. So that is s minus 365 equals our slope. And our 27, this is dollars per month, right? Since this is dollars a month, so it means we're saving $27 per each month. And so this will be 27, and then we're supposed to use m minus 6. And clean it up and we'll be done. So s equals negative, oops, not quite yet. S minus 365 equals 27m, and then that will be minus 162. And then from here we'll just add over the 365. And our equation is going to be S equals 27m, and then that came out to 203. So it looks at at t equals 0, we put in $203, and then each month we're saving $27 for that example. And then the last one here, suppose you're driving, let me grab a quick drink. Alright, that's better. Suppose you're driving and notice that after 4 hours you're 150 miles from Seattle. You continue driving and calculate that after 8 hours you are 270 miles from Seattle. Write an equation to model this situation. And then here they wrote use m for miles and h for hours. I wish they had written use h for hours and m for miles. Again, because I've done a couple gazillion of these, I know that time is almost always the independent variable, but it'd been nice if they had been a little more consistent in how they listed that down below. But the points are going to be in the same order as they have them up here. So we're using h for hours, and we're using m for miles. So our points would be in 4 hours we're 150 miles from Seattle, and in 8 hours we are 270 miles from Seattle. So let's get our rate of change. So we'll say slope equals 270 minus 150 over 8 minus 4. And that will be 120 over 4, or 30. So we're getting 30 miles per hour farther from Seattle. So with each hour we're traveling 30 miles. The mistake people do make on this problem is they assume that they started in Seattle. That is not necessarily the case. The only information he has is at 4 hours you're 150 miles from Seattle. So we'll still do our point slope form and figure out where we actually started. So y minus, again, either point is fine. I'll use the smaller one. 150 equals our slope, which is 30 times, I used y. Get rid of that. And so I should be using miles. 30 and then h minus 4. So cleaning this up, I get miles minus 150 equals 30 times h, and then minus 120. Add that 150 over, and we have miles equals 30h, and then that'll be plus 30. So it looks like we're starting 30 miles outside of Seattle and then traveling 30 miles per hour, 30 additional miles each hour on the trip. Cool, hopefully that helps out with point slope form.